Hello everyone, this is our session 6 on vectors. We are going to do exercise 5.3 now. This is based on the scalar product of two vectors. The first question that I'm taking is question 2. If a bar and b bar are two vectors perpendicular to each other, prove that a bar plus b bar the whole square is equal to a bar minus b bar the whole square. Okay, so let us begin with question 2. So this is exercise 5.3, question 2. Okay, so the question 2 says a bar and b bar are two vectors which are perpendicular. So dot product says that if the vectors are perpendicular, then their product is 0. That is, you have to prove a bar plus b bar the whole square is equal to a bar minus b bar the whole square. Okay, we know that a bar dot b bar is equal to 0 when, since a bar is perpendicular to b bar, it is given that the vectors are perpendicular to each other. Okay, so we write that a bar dot b bar is equal to b bar dot a bar is equal to 0. Okay, now we'll take the left hand side. Left hand side is equal to a bar plus b bar the whole square. Let us do the expansion. So it's basically a bar plus b bar into a bar plus b bar. Okay, so when you multiply the two, what do you get? A bar plus b bar, that is a bar square, rather we write as a bar dot a bar plus a bar dot b bar plus b bar dot a bar plus b bar dot b bar. Okay, now a bar dot a bar, what is a bar plus b bar when the vectors are perpendicular? 0 plus b bar dot b bar. Okay, that is a square plus b square. Okay, dot product of same vectors is magnitude of the, square of the magnitude. Let's take the right hand side now. Right hand side is equal to a bar minus b bar the whole square, which is a bar minus b bar into a bar minus b bar. Okay, which is equal to a bar dot a bar minus a bar dot b bar minus b bar dot a bar minus plus b bar dot b bar. Okay, now again this will be equal to a bar dot a bar minus 0 plus b bar dot b bar. Dot product of the same vectors is magnitude squared. Okay, so this will be square. Therefore, we have LHS equal to the RHS. Okay. So if the the two vectors are perpendicular, then we have a bar plus b bar the whole square equal to a bar minus b bar the whole square. This was question 2. Let's move to the next one. Doing the question 4 now. Okay, so question 4 is, show that the sum of the lengths of projections of pi plus qj plus rk, it is pi cap plus qj cap plus rk cap, on the coordinate axis where p equal to 2, q equal to 3 and r equal to p equal to 2, q equal to 3 and r equal to 9, r equal to 4 is 9. Okay, so basically you have to find the projection of this vector, okay, on each of the axes, that is x-axis, y-axis and z-axis. Okay, so how do we do this? So let us begin with calling this as the a bar vector equal to pi cap plus qj cap plus rk cap. Okay, projection of A bar, projection of any vector, okay, on x-axis is given by A bar dot I cap upon magnitude of I cap. Okay, so let us substitute the vector A bar, which is P I cap plus Q j cap plus R k cap, okay, multiplied by I cap upon magnitude of I cap is 1. Okay, now when you do this multiplication, it's basically doing dot product. So I into I will be 1, so we get P. J into I or I into J is 0 because they are perpendicular vectors, so theta angle between them is 90 and cos 90 is 0. Again, K and I are again perpendicular vectors, and so multiplication of those would again be cos 90, that is 0. So dot product of different unit vectors is 0 and same unit vector is 1. So we have P upon 1, which is 2. What is value of P from the sum? If you can see, it is 2. So when you did this, you did for x-axis, we did I cap, that is multiplied by I cap. So for y-axis, it will be multiplied by j cap, that is dot product with j cap, and z-axis dot product with k cap. So you can write over here similarly projection on y-axis is equal to q, which is, what's the value of q? 3. And similarly projection on z-axis is r, which is equal to 4. Therefore p plus q plus r will be equal to 2 plus 3 plus 4, which is 9. Okay, so sum of the projections of the vector on the axis is given by 9. Okay, let's go to 5, the next question. Okay, so question 5. Suppose that all sides of a quadrilateral are equal in length and opposite sides are parallel. Use vector methods to show that the diagonals are perpendicular. So let us first take a quadrilateral. Okay, and we'll call this as A. Okay, so question 5 says that ABCD is a quadrilateral in which all the sides are equal and opposite sides are parallel to each other. So I have written that ABCD is a quadrilateral wherein AB, BC, CD and AD magnitudes are equal and opposite sides are parallel. Now when vectors on opposite sides are parallel, we can also say that those vectors are equal. So I have written AB bar equal to DC bar and AD bar equal to BC bar. Okay, now let us consider the first diagonal, that is AC. So AC bar is equal to, it will be from the diagram, if you can use triangle laws, then it will be AB bar plus BC bar. Okay. And diagonal BD, okay, is equal to, what is diagonal BD equal to? BC plus CD. BC bar plus CD bar. Okay. Which can be written as CD is equal to AB, we can write. So minus AB bar plus BC bar. Okay, that is from the second point that we have. What is the second point? You can see that DC is equal to AB, right? So CD will be equal to minus AB. Here I'll write it so that it's easier to remember. Since I'm taking the opposite vector, so it will be minus AB, which is BC bar minus AB bar. Okay, and here we can write BC bar plus AB bar. Okay. Now what we'll do is we are going to take the dot product of these two vectors. Now when the dot product is 0, okay, when AC and BD will be 0, that is dot product would be 0, then the theta angle between them would be 90 and then the diagonals will be perpendicular. So let's take the dot product. It will be BC bar plus AB bar multiplied by BC bar minus AB bar. Okay, let us do the dot product. So we'll get BC bar into BC bar dot BC bar, okay, plus, sorry, minus BC bar dot AB bar plus AB bar dot BC bar, sorry, minus AB bar dot AB bar, okay, minus AB bar dot AB bar. Now this can be written as BC square, okay, same dot products, we take the magnitude square. Now minus BCAB plus ABBC can be written as minus BC dot AB, okay, plus BC plus AB dot BC, sorry, minus AB now from the dot products we know that BC dot AB, okay, will be equal to AB dot BC. So basically both are same, so they cancel out and we are left with BC square plus AB square. Now BC square magnitude minus AB square magnitude can also be written as BC square magnitude minus BC square magnitude. From where? From 1 we can say, why? Because these magnitudes are equal, that is all sides are equal to each other and therefore we are getting 0. So we've got the dot product of the two diagonals, that is AC dot BD equal to 0 and therefore they are perpendicular to each other. Okay, moving on to question 6. Determine where A bar and B bar, whether A bar and B bar are orthogonal, that is perpendicular, parallel or neither. Okay, so when would they be orthogonal? When their dot product is 0. When would they be parallel? When one is a scalar multiple of the other. And when would they be neither? That is, you don't get them 0, you don't get them scalar multiples. Then it is neither orthogonal nor parallel. So I'll just solve the first one in this question 6, first one. Okay, so A bar is equal to minus 9 I cap plus 6 j cap plus 15 k cap, and B bar is equal to 6 I cap minus 4 j cap minus 10 k cap. Okay, so now let us take the first vector, 9i plus 6j plus 15k. So you can see that 3 is common in this, so I'll take 3 outside. I have 3i plus 2j plus 5k. Okay, now if you can observe, you have 6i, 4j and 10k in B bar. Can I convert this vector into B bar? So let's see, let me try and do that. So we'll have 3 upon 2 multiplied by 2. So I'll have 6i cap plus 4j cap plus 10k cap. Yes, this is possible. Okay, now what is the problem is the sign, right? So what I can do is, okay, this is minus 9i cap. Okay, so what I can do over here is I can take minus sign common. When I take minus sign common, then A bar is equal to minus 3 upon 2, okay, 6i cap minus 4j cap minus 10k cap, which is equal to your b vector, so minus 3 upon 2b. So what am I getting over here? The first vector is a scalar multiple of the second vector, and therefore we can say that a bar is parallel to b bar, since a bar is a scalar multiple of b bar. Okay, so similarly you can do the second and third one, wherein you will have either the dot product 0, or you would have the dot product a scalar multiple, or you can check for if none of them is possible, then they are neither orthogonal nor parallel. Okay, now let's go to the next question. Question 7. Find the angle P of the triangle whose vertices are P, Q, and R. So we have to find an angle of a triangle with the vertices given to you. So let us take a triangle PQR over here. Okay, I have to find the angle P. Okay, so P, Q, and R vectors are given to you. What are these vectors? Sorry, vectors are not given, but coordinates are given. So let me write the coordinates first. P is 0, minus 1, minus 2. Q is 3, 1, 4. R is 5, 7, and 1. Okay, so how do you write their vectors then? So we can write P bar is equal to 0 I cap minus j cap minus 2k cap. Okay, Q bar is equal to 3 I cap plus 1 j cap plus 4k cap, and R bar is equal to 5 I cap plus 7 j cap plus 1 k cap. Now when I have to find angle P, then I require QP and PR, okay, or PQ and PR. So if I require PQ and PR, that means I require distance PQ and distance PR. I require magnitude of them, I need their vectors, right? And then I can take their dot product. So when I take PQ bar dot PR bar, okay, which is PQ magnitude, PR magnitude into cos of angle between them is P, right? So when I do this, then I'm going to get my value of cos P. So what do I require for this? I require vector PQ, I require vector PR, and I need their magnitudes as well. Okay, so let us begin. We are going to first find out the vector PQ. So PQ is equal to, by distance formula, Q bar minus P bar, okay, which is equal to 3i plus j plus 4k, 3i plus j plus 4k minus, what is P bar now? 0i plus j plus 2k. 0i plus j plus 2k. Okay, I've changed the signs already. So this will be 3i cap plus 2j cap plus 6k cap. Okay. Similarly, okay, we can find out PR bar, okay, which is R bar minus P bar, okay, which is equal to 5i plus 7j plus k, 5i plus 7j plus k, okay, minus P bar, that is 0i plus j plus 2k. Again, I have already changed the signs, that's why I'm not putting the brackets. 5i minus I is 5i only, 0i that is, plus 7 plus 1 is plus 8j and plus 3k. Okay, so this is PR bar. I have both the vectors. Now let's take their dot product. So that is PQ bar dot PR bar, okay, which is equal to the two vectors dot product. What is the two vectors? 3i plus 2j plus 6k, 3i plus 2j plus 6k, okay, dot product by 5i plus 8j plus 3k, 5i plus 8j plus 3k, okay. which is equal to, now you know that when you take dot product, only the similar unit vectors will give you an answer, the remaining are 0. So 3 into 5 is 15 I cap, okay, I cap into I cap basically, that is 1, plus 2 into 8 is 16 j dot j, okay, which is again 1, and plus 6 into 3 is 18 k dot k, okay, which is 1 again. So we have 15 plus 16 plus 18 over here, which is equal to 49. Okay, now this is your dot product. Now let us find the magnitude separately, that is PQ bar magnitude separately, which is square root of the coefficients of PQ. What is PQ bar? It is 3, 2 and 6. So square will be 3 square plus 2 square plus 6 square, that is 9 plus 4, that is 13 plus 36, that is again root of 49. So it is 7. Okay, this is PQ bar magnitude. PR bar magnitude will be square root of, what is our vector PR bar? Let's check. 5, 8 and 3. So it's 5 square plus 8 square plus 3 square, that is 25 plus 64 plus 9. Okay, 25 plus 9 is 34 plus 64, that is 78. Okay, so square root of 78, which is 7 root of 2. Okay, this is magnitude of PR. Now using the formula, we are going to find cos P. Now from where did I get the cos P formula? I'll just go behind and show that to you. So you can see cos P over here is the dot product upon magnitudes. Okay, so we will have cos P equal to PQ bar dot PR bar, okay, divided by magnitude of PQ bar upon into magnitude of PR bar, okay, which is equal to, what is PQ bar dot PR bar? We have done the dot product 49. Yes, it's 49. So 1 second. 49 upon PQ bar dot PR bar, that is 7 into 7 root of 2. Okay, so which is 49 cancels out and you have only 1 upon root 2. So what is the value of angle P? It's clear, cos P equal to 1 by root 2. That means cos P equal to cos of 45. Therefore, P is equal to 45 degrees. Okay, so this is the value of angle P. That is how you would find the angle between any of the vectors. Okay, now I'm doing the last sum for this exercise, that is upon direction ratios. So if that's the 12th question. So question 12. Okay, question 12 says that if a line has the direction ratios 4, minus 12 and 18, then find its direction cosines. Okay, so direction ratios means basically A is equal to 4, B is equal to minus 12, okay, and C is equal to 18. These are your direction ratios. Then we have to find the direction cosine. So we'll say L, M and N be the direction cosines. Okay. Now L is equal to A upon root of A square plus B square plus C square. Okay, which is equal to, let us substitute the value. So 4 upon root of A square is 16 plus B square is 144 plus C square is 324. Okay, which is equal to 4 upon under root of let's add that, that is 10 and 4 14, 1 to 6 and 2 8, 3 4 and 5, 584, which is 4 upon 22 okay, which is 2 upon 11. So L is equal to 2 upon 11. Similarly, you can find out M equal to, that is B upon root of A square plus B square plus C square, okay, which is equal to minus 12 upon root of 584, okay, which is equal to minus 12 upon 22. 2 6 and 2 11s, so minus 6 upon 11, okay, and then N, the third direction cosine, so C upon root of A square plus B square plus C square. So basically we need to know our formulas well, then this chapter itself is very easy once you understand the basics of your vectors. Okay, 18 upon 22, which is 9 upon 11. So the direction cosines are 2 upon 11, minus 6 upon 11 and 9 upon 11. Okay, so here I'm completing exercise 5.3. Most of the types I have covered. If there are any doubts regarding the same exercise, you can write to me. I will send you the solution. In the next session, we are doing the vector product and the sums based on them. Thank you so much.